Okay guys, welcome to my YouTube channel. Let's talk on chain rule under differentiation. What is chain rule? Chain rule is also called the function of a function, whereby the y, the x can be written as dy du times du dx, because the u can actually easily cancel out the u and you get back your dy dx. This is function of a function where u is just a variable. We can as well write a function of a function in another form, dy du times du dk times dk dx, where the k cancel out the k and the u cancel out the u and you get back your dy dx. So this is function of a function. This can actually continue even until forever, depending on the number of function of a function in a question given. For example, we should take an example that says 3x plus 8 all raised to the power of 6. This is y equals to 8. Now we are asked to find the dy dx of this equation. Now how can we find the dy dx of this? We can't just subtract 1 from the power and then multiply with this power at the back. No, it is not allowed, because this is not raised to the power of x. It is raised to the power of the whole of this. And if that is not possible, we would change 3x plus 8 into a single variable so as to be able to minus 1 from the power and multiply at the back of that variable. You get? So now let's say u equals to 3x plus 8. Now changing this to u, we say y is equals to u raised to the power of 6. Now this implies that dy, now we are in the u word, we are not in the x, so we would say dy du is equals to 6u raised to the power of 5, subtracting 1 from the power and multiplying with the power. Now from this we would have to find from there, we would have to find du dx. The u is depending on x, so we have to find du dx, and that would be what? That would be 3, because differentiating 3x you get 3, and differentiating 8, which is a constant, you get 0, right? So now from here you have your dy du and your du dx, but from the formula, which we know that dy dx is equals to dy du times du dx. Now to have our dy dx, we would have to multiply dy du and du dx, and that would be what? That would be 6u raised to the power of 5 times 3, and that is equals to 18u raised to the power of 5. Now we would have to change our u back to the expression with x, because we are asked to find dy dx, so there should be no u in the answer. So dy dx equals 18 in bracket 3x plus 8 raised to the power of 5. So this is the answer to when you are asked to find dy dx of this equation. So let's move to another example. In this example, we are asked to find y dy dx when y equals cos in bracket 5x squared minus 2. you should notice that we always turn the expression with x in it into a single variable, as long as this in the course is not just x or a single variable. Is as complicated as this 5x squared minus 2. We have to turn it into a single variable, because that is when we can actually differentiate it. So we say y, let u equals to 5x squared minus 2. So from here you know that du dx equals 10x minus 0, and that is 10x. So from there you say y is equals to cos. Now this is no longer 5x squared minus 2. For now, we change it to u, and differentiating this, we have dy du equals negative sine u. So now we multiply them together so as to get our dy dx, and that is to say that dy dx equals, multiplying this with this, you get negative 10x sine u. Now instead of writing your u, you go back to the one with the x. Now you know u is equals to 5x squared minus 2. So you replace your u with 5x squared minus 2. And that's the answer to this question. Now let's look at another example. Now example, y is equals to sine 2x all raised to the power of 2. Notice sine 2 depends on the power of 2. Therefore, we can actually make sine 2x a single variable so as to be able to differentiate that single variable raised to the power of 2. We would find dy in respect to the single variable we are turning sine 2x raised to the power of 2. Now, what could be that single variable? It can be anything. I normally use x. You can use anything for that. Say u equals to sine 2. Now we'll come back for this. Now let's change this as u. Then we say y to u squared. Dy du equals to 2u. Now we get our dy du. Now from here, you should see that it is also not a single variable inside the sign. The sign does not have a single variable in it. It also have 2x. I wish it was x. We can differentiate directly, but this is 2x, meaning that we have to as well do another chain rule for this expression. Now we won't want to use u again, but use another variable, and let's say that variable should be k. Let k equals to 2x. Now from there you see that the k dx is equals to 2. Differentiating this, you have to now replace 2x as k in this. You come down here and you get that u is equals to sine k, right? Now du dk is equals to cos k. Remember from the example I gave, from the illustration I gave earlier, from the starting of this video, I said we can say dy dx is equals to dy du times du dk times dk dx. When they all times themselves, like dy du times du dk times dk dx, when they all multiply themselves, this cancel out this cancel out this, and you get back your dy dx, right? Now our dy dx is therefore the multiplication of these three answers we got, and that is 2 times 2u times cos k, and this is equal to 4 times, what is u? Our u is sine 2x, and that is sine 2x. And what is cos k? Cos k from this is 2x. So the answer to the question is 4 sine 2x cos 2x. That is, when you differentiate sine 2x all raised to the power of 2, you would have 4 sine 2x cos 2x. I hope you understand the meaning of function now after watching this video. Thank you for watching. Leave a like and a comment. Thank you for watching this video.